I am Yogesh Jangle, working as Assistant Professor, Department of Mechanical Engineering, Walchand Institute of Technology, Solapur. Today, we are going to discuss about GD&T topic. In this topic, the learning outcome is student will be able to understand GD&T symbols on production drawing, and students will be able to read industrial drawing. The content to be covered today is 14 symbols of GD&T and some tolerances or symbols. We are going to discuss straightness, flatness, circularity and cylindricity. This is already we discussed for the last lecture regarding what is the need of GD&T and what is GD&T. Just go through the slide. 14 symbols also we discussed for the last lecture. There are total 14 symbols which categorized as form tolerances, orientation tolerances, location tolerances, runout and profile tolerances. Among this, we are going to discuss about straightness. First tolerance, it comes under or it's categorized under form tolerances, which define the basic form of a element or a feature. Straightness, generally, it controls the form of a line somewhere on the surface of the feature. Simply, if I want to maintain the straightness of edges, which is on the part basically, then the straightness symbol is used. You can see in the cube over here, and these are the lines along with these references. Simply, it is going to be checked whether the specified edge is within a straight or not. It is indicated with a feature control frame as we discussed for the last lecture. I want to maintain the straightness of this edge within a tolerance of 0.02. What is 0.02? It is nothing but a tolerance. I can say each I can say element should lie between the two lines spaced between 0.02, that is a tolerance zone. These two dotted lines indicated over here, it is a tolerance zone of 0.02. So how this straightness can be inspected? It can be inspected with the help of dial indicators. Okay. The part is oriented parallel to the running axis of the dial indicator. This is the first thing. Second thing, dial indicator is run along the line of in the direction of required for straightness control. Okay. If the full dial indicator moment, the maximum movement of the dial exceeds the straightness control tolerance basically. Suppose we have ranges given a range of 0.02. We have set the same for the dial indicator. If it is exceeds, then that edge is not straight. Basically, we can say it in that way. Cylindrical surface straightness. There are two types of straightnesses we generally measure. That is flat surface straightness or cylindrical surface straightness. Cylindrical surface straightness is generally measured to the element upper edges should be straight. Again, the part is constrained and gauge is moved along the straight line on the surface or element to be measured. Okay. When the plunger moves up and down, up and down the pointer moves, and the full movement of pointer gives the deviation of the surface. Again, the indication over here, the upper edge or in this edge should be straight within a tolerance of 0.5. Next, how it is going to be inspected? Straightness can be inspected with the help of simply a wire with a diameter which is equal to the straightness control frame tolerance basically. If a wire with a diameter equal to the tolerance zone width is used to inspect at each location on the cylindrical surface, if the wire fits between the part and the surface plate, then the straightness error is too large and part is out of specification, we can say it in this way. So, axis straightness is also one of the, I can say, third parameter. We can measure the axis whether it is straight or not, and it is indicated over here. The indication is totally different. It is indicated over here to the basic size only. Okay, 530 mm diameter with a tolerance of 0.1. This is a dimensional tolerance. And this indicates a geometrical tolerance. That means the axis should lie within a diametrical tolerance, the diametrical tolerance symbol is indicated over here, that is a phi symbol. Okay, it is a diametrical tolerance zone of 0.5 mm. So the difference between straightness of surface and feature of size, simply it is measured, you can see surface lines are not straight but axis is straight. In that case it is generally used. And second case, axis derived median line is not straight, and you can see the straightness symbol is given to the upper edge over here, and straightness symbol, or I can say that GDNT symbol, is given to the dimension itself. This is the basic difference. And again, this phi indicates dimensional tolerance. This is nothing but a linear tolerance simply. Inspecting straightness of axis, again it is indicated or it is measured with the help of dial gauges in this way. When to use axis straightness and surface straightness, okay, here it is given. Sealing surfaces or surface that mate another part, generally these are the application of where to use axis straightness and surface straightnesses. Okay. Hydraulic cylinders which require sealing of pressure. When axis control with MMs is used to pin or cylindrical feature which must be installed into bore or hole. These are the application of straightness. Next, I can say symbol we are going to discuss about flatness is indicated over here. You can see again in feature control phase there are two boxes. One box indicates above symbol, second box is a tolerance. Okay. Flatness is the degree of variation in the form of complete surface, not only the straight line or segment but full surface we are going to consider. This full, I can say, highlighted surface we want to measure, it should be flat within a tolerance of 0.02. Okay. All the elements of the surface should be lie between the two parallel planes with 0.02. This 0.02 is nothing but two dotted lines indicated over here, and this surface should lie within these two dotted line only. Then we can say it is exactly flat. So again it can be measured with the help of indicator only, but it is inverted indicator is assembled to the can say surface plate which is having a hole, and upper part can be moved to the any of the direction so that it should be within a tolerance zone. This is the indication of inspecting method for flatness. Inspecting flatness using CMM, we can do it using CMM as well. This is one of the, I can say, method to measure the flatness. This is one example over here. You can see this overall surface. This surface is nothing but it is exactly it is maintained with the flatness of 0.1. Okay, and the same surface is used for a as a reference for other feature to be tolerance or geometrically tolerance. That is a profile of surface and profile of line. So that the major or datum surface which is, it must be flat, then only the other parameters may be in the range given to the tolerance zone. This is one of the industrial example which uses a flatness for sheet metal parts. Mostly sheet metal parts are not a unique one. It may be bent anywhere. You can see in this case, if the parts are bended due to the welding process, again it should be maintained with a flat surface and it should be maintained with a tolerance of 0.1. As per the manufacturing process, the deviation, I can say, undulation may be formed on the sheet metal surfaces. So to maintain that, we have to give, I can say, geometrical tolerance for this. Next is the circularity. In circularity, again it is indicated with the two symbols. First one is nothing but a circular symbol. Second box indicated with a tolerance zone. Okay. Circularity is the condition of cylindrical surface. It is measured at exact at that element only. Okay. And if you want to measure the deviation, it should be within a tolerance of 0.02 over here. These two center axis circular part, this is nothing but a tolerance zone. The profile must be fall within this tolerance zone. Then only we can say it is circular one. Again, it is inspected with the help of, you can see, this is turntable provided over here. On turntable, we can keep a part, and this is the indicator over here, measuring probe, which can be measured with just like as a dial indicator only. So we can rotate the turntable, we can measure the circularity at the section only. I repeat, at the section only. Okay. Why I'm going to talk about at this section, we'll discuss in the next session. Just be patient. Next is nothing but a cylindricity. Okay. As per as circularity we discussed, there is one more I can say geometrical term. There is a cylindricity considered over here. It is measured along whole length. In a circularity, at that section only it should be circular, but in cylindricity it should be circular and cylindrical both throughout the length. Throughout the length. Okay. So these are the advantages or I can examples of I can say cylindricity and circularity. You can see the bearings generally use this circularity and cylindricity profiles. Crankshafts are generally whatever the circular profiles are there, it can be maintained with the help of circularity and cylindricity symbols. Notes on circularity, cylindricity as we discussed. Circularity at that section and cylindricity throughout the length of cylindrical part, it is measured. This is the major difference between circularity and cylindricity. Okay. What is the difference between the surface straightness versus cylindricity? Straightness at that upper edge only it should be straight and it is applicable for the flat surfaces as well. Okay. And cylindricity, it is circular tolerance zone is provided for the cylindricity. In both the cases, feature control frame is same. First box indicates symbol, second box indicates tolerance. Okay. So for these sessions, I referred ASME standard 14.5 2009 dimension and tolerances and machine drawing by ND Bhatt. Thank you all for listening. Thank you.